Hello, fellow ship teleporters. Welcome back again to the Love of Omega Gateway, upcoming 4X turn-based sci-fi game on the works. Last time we implemented our way through Unity's event system for the game to recognize on events when a turn is passed, and modify the ship so it actually moves from one space to the other. The problem is that after we pass the turn, the ship just teleports to the section we indicated. We need to set a path there. This brings us to a new challenge. How can we tell what's the best route from wherever the ship is to where the sector is, also avoiding obstacles like territory that we can't walk through? Well, one of the most reliable ways to solve this problem is to apply the A-star search algorithm. A-star is a path search algorithm well known for its efficiency and is used a lot in the computer programming field. Although there are more performant ways of doing the same thing out there, like for instance the ones that involves pre-processing data, this one is very efficient and will do very well for us. I am not going into details on the academic rationale on why it works so well, because there is tons of info about that everywhere in all the languages, both code and spoken. Nevertheless, let's go through the steps of the algorithm to define it for ourselves. First, we need two lists, a visited list and an active list. We take the first node, a coordinate in our case, and set it into our active list. Then we follow these steps until all the active list is empty. We take the coordinate with the least cost plus distance from the active list. We will define that cost and that distance in a moment. We will call this sector to check. We verify if the coordinate is in fact our destination. If it is not, we continue. We remove the sector to check from the active list and add it to the visited list. This is where the magic happens. We get all the walkable neighbors from the sector to check, and for each we assign a cost. That cost is the number based on whatever business logic we have. In our case, we can use it to prefer to avoid nebulas, for example. And then we also assign the real distance without obstacles from that sector to our destination or not known. We also set the sector that we are checking as a node parent. This is very important because the final result will be the list of the nodes that are nested as parents of each other. Now, for every neighbor we got, we first check if it is on the visited list. If it is, we ignore it. Then we check if it is in the active list. This will mean that this is a viable path for the time being. If it's not, then we add it for later validation. If it is on the active list, we evaluate its cost with the sector to check. If it is lower, we can just remove it from the active list. Eventually, one of two options will happen. Whether our sector to check is equals to our destination is true, and so the path can be expressed as the nested node parents of the sector to check until there are no more parents, or the active list will be emptied because we iterated through every possible coordinate and thus there is no pathing there. Let's go to the implementation in our project. First, we need to add a few extra stuff on the Galaxy Coordinate class. A few methods to get the neighbor in all 8 directions. If that neighbor doesn't exist because it's the end of the map, we will return null. Then a small class that we will call pathing node that will hold the pathing information, like for instance the cost and a quick way to get the distance between two coordinates. We will also define the method to unfold the pathing when we get it. Now to the actual algorithm. We will implement it on the Galaxy Manager because it has all the information we need between a source coordinate, let's say a fleet, and a destination, another coordinate or sector. First, we create the actual lists that we are going to fill and empty over the course of the algorithm. We will call them active list and visited list. We will also get the starting sector from the fleet that we are checking. Before we start, we add that starting sector to the active list. Then a simple while loop that checks if there is something on the active list with the expression any. Of course, on the first loop we will have the starting sector. After that we choose which sector we are going to check. We choose the one with the least cost distance using the expressions order by and first. We get that cost distance by invoking the pathing node we defined earlier on the Galaxy coordinate. Next thing is a very simple check to see if the node we are checking is the actual finish line. For that we use the equals method we overrode, have overridden. In any case, it will check if both coordinates are the same. If they are, we are where we should be, and we start the unfolding of the parents of the pathing node. In reverse, This is because the first node in the list is going to be the destination coordinate and vice versa. But if we are not there yet, we need to continue. We take the sector we are checking and move it into the visited list. This sector is not going to be checked anymore. We need now to get the neighbors of the coordinate and its costs. So we define a new private method, get possible neighbors to walk, and we set as parameters the starting sector, the sector we are checking now, and the destination. I know ships don't walk, but the reference is very clear. The method to get the neighbors will first call the actual neighbors of the sector, without any business rules. So basically this method will return any sector that exists. It doesn't matter the rules it has. Then we take each of these neighbors and assigning the cost, composed by its own cost plus the cost of the sector we are checking. For the time being, every sector has the same cost, so we return 1 on each. In the future, we can make certain walkable sector less desirable to pass through with this. Then we assign the sector we are checking as its parent. After that, we set the distance on each of them. Remember that we already defined a small algorithm to calculate the distance as a number. Finally, we return the list. But before that, we filter which sectors are actually walkable according to our business rules. In this method, we are defining called canFleetAccessSector. We return true or false if it can. In the future, it is here where we are going to prevent fleets from entering sectors if they can't. For example, when dealing with other players' territories or if the sector is beyond its range. For the time being, fleets can enter any sector. So, back to the main algorithm. We already got all the neighbors that the fleet can pass through. Now, for each of these walkable sectors, we first verify if there are any of the visited list. If there are, we just ignore them with a continue keyword. Then we check if that neighbor is in the active list. If it is not, we add it. The algorithm will verify it in a later step. If it is on the active list, we verify if the cost plus distance of that neighbor is more expensive than the sector we are checking. If that is the case, we remove it. So we define a return statement when we find the path. If the while loop checking if there are elements in the active list stops, that means there is no path. We will return null in that case. Are you still with me? Good, because that was it. Let's see if it works. First of all, we will add a super simple sprite in the sector prefab. This circle will be off by default, but we will turn it on if we are pathing over that sector. We add a new attribute on the sector class that holds it, called movement indicator, and add a couple of methods to turn it on and off again, called drawPath and clearPath respectively. Then on the onHover method, we will check if there is a fleet selected, just like we did in the onAction method. If there is, we will call a new private method to deal with this action, named handleSelectedFleetHover. On that one, we will call our newly made path between sectors from the Galaxy Manager. We will send the fleet as the source parameter and the sector itself as the destination. There are two options here, whether the algorithm finds a path and then returns a list, or it doesn't and it returns null. We don't do anything in that case, but if we do find the path, we will ask all the sector involved to draw its movement indicator. So testing it, it seems to work, but as you can see, we need to clear the movement indicators before we try to draw a new path. Back to the code. We will define a quick clear sector paths method on the Galaxy Manager class that just iterates over every sector on the grid and calls the clearPath method we defined earlier. We will call this method before we do onHover on the Galaxy Sector class. And now this looks way better. It seems to be working, but it's hard to know because we don't have any rules on the pathing. We don't have any walls to deny or walkable tiles. Let's change that just for the sake of testing. Let's go back to the canFleetAccessSector method that is just returning true and set a random rule. Let's say that if there is a system, you cannot enter the sector. With that in place, let's hit play and look at that. The chosen pathing is clearly only considering the systemless sectors because of our random rule. We can set any real rule in the future. We almost forget about the last step, moving the ship. This will be very easy though, because if you remember in the last episode, we said that when you action over a sector, you send a list of coordinates as a parameter. That list of items are queued as individual actions for the ship. So instead of sending a single coordinate, we just call the A* method again and we push those coordinates in the list. that should be it. The ship moves over the indicated sector, avoiding those pesky systems as we said in that random room. Alright peeps, I'm very happy with how this looks right now. The basics are starting to come together and to form something concrete. Thanks for joining me on another episode of this adventure. And if you want to be part of it, or at least learn how to make weird games on Unity with a dude with a funny accent, don't forget to like the video and subscribe to the channel. Cheers friends, and see you in the next episode.